Let's have a discussion about dividing rational expressions. I'm going to introduce you to rational expressions, and then we're going to talk about the steps that I recommend that you follow when you are dividing rational expressions. And then once we're done discussing those steps, we're going to look at some examples together. So what are rational expressions? It's a fraction that has a polynomial in its numerator and also the denominator. Let's look at one or two examples. We have x cubed minus 2x divided by 3x squared plus 4. That's one example. Another example could be 2x plus 3 divided by 3x to the 5th power. So these are examples of rational expressions. So how do we go about dividing rational expressions? First of all, we want to factor the numerator and denominator in each of the rational expressions. And then after that, we're going to express the rational expressions as a product of its factors. And then we have to follow the rule of dividing fractions, because remember that rational expressions are presented as fractions. So what we're going to do is we're going to flip the numerator and denominator of the rational expression on the right side of the division symbol. Remember, if you had something like this, 2/3 divided by 1/3, what you would actually do is you're going to leave the fraction on the left alone. You're going to change this symbol to a multiplication, and then you're going to switch these fractions. You're going to switch the numerator and denominator of the fraction on the right hand side, which becomes 3/1. So we're going to apply the same technique to rational expressions. And then once we're done with that, we're going to cancel out common terms in the numerator and denominator, and then whatever is left over is going to be the solution to the problem. So let's go ahead and see how we can apply these rules that we've discussed, or these steps that we've discussed, with real example. Okay, so we start with 3a squared minus 3a minus 36. We factor out 3. We have a squared minus a minus 12. And this is going to be the same as a minus 4 multiplied by a plus 3. The next one is 2a squared plus 8a minus 10. So we factor 2 out. We have a squared plus 4a minus 5. Then we have a squared minus a minus 12. This is going to be a minus 4. And then we have a plus 3. And then finally we have a squared. Actually, forgot to factor this one out. So this is going to be 2. We have a plus 5, a minus 1. Then here, the last one is a squared plus 3a minus 10. This is going to be a plus 5, and then we have a minus 2. So let's go ahead and replace them. So we're going to go ahead. I'm going to make this a multiplication over here because we're going to switch it around. So this is going to be 3, and then we have a minus 4, a plus 3, divided by, we have 2, a plus 5, and then we have a minus 1. And now we're going to do a flip on the right hand side. So we're going to have a plus 5 and then a minus 2 over a minus 4, a plus 3. So now we've done the flip. So now let's go ahead and look at crossing out common terms. So we have a minus 4 here, a minus 4 goes out here, a plus 3, a plus 3. We have a plus 5, a plus 5. So now let's go ahead and see if there are any other common terms. So right now we cannot find any other common terms. And so our answer is going to be 3a minus 2 divided by 2a minus 1. You can go ahead and distribute this, but for the purpose of this, we're just trying to show how to simplify, so it's not that important. Let's go to the next problem. We have x squared minus 9x minus 10. This is going to be x minus 10, x plus 1. If you have any difficulty with understanding this, we can go back to the module or the video on factoring quadratic expressions. And then here we have x squared plus x minus 6. This is going to be x plus 3, x minus 2. And then we have x squared minus 1. This is x plus 1. And then we have x minus 1. Then we have finally x squared minus 4. This is going to be x plus 2 and then x minus 2. So what I'm going to do here is I'm going to create another layer in between, and I'll show you exactly what I'm talking about. So we're going to replace, I'm just going to replace everything exactly the way it is. So we have x minus 10, x plus 1 over x plus 3, x minus 2. I'm going to leave the division symbol. This is what I mean by saying I'm going to add an additional layer. So this is going to be x plus 1, x minus 1 over x plus 2, x minus 2. And then we'll go ahead and now do the flip right here in this step. So we have x minus 10, x plus 1 over x plus 3, x minus 2. And now that we've changed this to a multiplication, we're going to have x plus 2, x minus 2 over x plus 1, x minus 1. So now we're going to do our cancelling. So we're going to cancel our common terms numerator, denominator. So we have x minus 2 here and then x minus 2. We have x plus 1 here. We have x plus 1 over here. Are there any other common terms? No, we cannot find any. So what we're going to do now is our solution is going to be x minus 10 multiplied by x plus 2 divided by x plus 3 multiplied by x minus 1. So this is going to be the solution to this problem. And then our final example, we're going to do something similar. So we have 3x squared minus 25x minus 18. So let's go with 3x squared minus 25x minus 18. So you can see here that we cannot really factor out 3. So I'm going to use this slide and shift method. So this is going to be x squared. I'm going to slide this 3 over to 18 and multiply. So it's going to be 54. X squared minus 25x minus 54, which is going to give us x minus 27 and then x plus 2. So now that we have this, we're going to divide each of these by 3 because that's what we multiplied in the first place. So we have x minus 9 and then this 3 is going to move over here. So we have 3x plus 2. The next one is 27x plus 18. So we just go ahead and we have 9 as a common factor. We have 3x plus 2. And then we'll go ahead and we have 10x minus 6. That's going to be 2 as a common factor, 5x minus 3. And then the last expression here is 5x cubed minus 33x plus 18. And there's no 5 is not a common factor here, so we're going to do the slide and shift method, which is we're going to move 5 over here and multiply. So we have, this is x squared, 5x squared. So 5x squared, that's actually going to give us x squared minus 33x plus 90. So this is going to give us x minus 30 and then x minus 3. So now we're going to divide these constant terms by 5, divide by 5. So now we're going to end up with x minus 6, and because this is a fraction, we're going to move this over here. So it's going to be 5x minus 3. So let's go ahead and simplify. Well, now that we have created our factors, we have expressed each of these polynomials or expressions as a product of their factors. We're going to now replace each of them with their product of their factors. So this is going to be x minus 9 and then 3x plus 2. We divide this by 9 multiplied by 3x plus 2. And then we divide here 5, this is 2, and then we have 5x minus 3 divided by x minus 6, and then we have 5x minus 3. So what we can do here, I mean, there's some things we can do simply by just, let's see if we can simplify this the way it is. So we can take this out, 5x minus 3, 5x minus 3. So now our expression is going to look like this. X minus 9 over 9 divided by 2 over x minus 6. So now what we're going to do is we're going to change this to a multiplication. So this is going to be x minus 9 over 9 multiplied by x minus 6 over 2. So this is going to end up becoming x minus 9 multiplied by x minus 6 over 18. So this is going to be the solution to this specific problem.